This is Precalculus Chapter 8 review. All right, so the questions were problem number 1. So I set it equal to 0. I'll just show you what I put in my calculator. Setting it equal to 0. So I subtracted that 2 sine 2x. All right, so the period for 2x sine, that's 2 pi over 2, which is pi. The period for tan is pi. The period tells me what I want to see on my calculator. So I want to see between 0 and pi. So I actually went from, here's my window. I am going from negative 0.5 to right above pi. And then graphing it, this is what I see. So I think that one is clearly at 0. I'm going to do second trace number 2, which is 0 for that second one. And I'm going to get close. All right, I'm getting closer to the x-axis. I'll try to see. Watch it. It's barely going up. I'm just watching my y's. When it gets positive, it's still negative, isn't it? When it gets positive, I'll go back down. Okay, now it's positive. So I'm going to go back below, hit enter. I don't want to mess this up. And then I'll go above it, which is positive, hit enter, and enter for my guess. And it's 3.14, that's pi. So it's at 0 and pi. So it's going to repeat 0, pi, 2 pi. So really, the answer, there's only one solution. The answer is pi plus k pi. You could have written 0 plus k pi. But that's the same. All right, so that's for number 1. You have to know how to input it in your calculator. All right, number 14. Number 14. Let me tell you what page I'm on, guys. 564. 564. All right, so the inverse sine of the sine of 0.75. The inverse sine of the sine of 0.75. All right. The inverse sine of the sine of anything is always t, as long as that t is in the right quadrants when we take the inverse. The sine has got to be in quadrant 1 or 4. All right, so this is radians. Remember, when it's just the sine, the number right after it is radians. When we do the inverse sine, the number after it is the ratio. All right, 0.75 is in the first quadrant because it goes from 0 to pi over 2. That's like 3.14 divided by 2, which is like 1.57, which is greater than that. So this is in the first quadrant, so it's 0.75. It's the same. And there's a box about this. Let me tell you the page that it's on. On the top of page 532 for the sine, and on the bottom of page 533 for the cosine, which I believe the cosine was the next one. Next question, that was 14. 15 is the cosine. Okay, for the sine, we're going in quadrants 1. Inverse sine, quadrants 1 and 4. For the inverse cosine, we're in quadrants 1 and 2. All right? So this is number 15. Inverse cosine, cosine of 2. That's my radians. Because when I take the inverse, I've got to be in quadrant 1 or quadrant 2. Quadrant 1 And 2 is any number between 0 and pi. Pi is 3.14. 2 is between 0 and 3.14. So the answer is that. Number 18, you do not have to know, nor number 19. So you're not going to have to sketch a graph. Then we're going to number 33. All right, so number 33 is 4 cosine squared x minus 2 equals 0. I'm going to add 4 to both sides. Divide by 4 on both sides. I'm not going to simplify that to 1/2 because I'm going to take the square root. When I take the square root, it's cosine x is plus minus. 2 stays under the radical. I can unsquare 4. It becomes 2. All right, so I have 2 solutions. The cosine of x is positive square root of 2 over 2. And the cosine of x is negative square root of 2 over 2. Well, that's going to be in every quadrant. In quadrant 1, lower this just a little bit. In quadrant 1, that is pi over 4. In quadrant 4, that's going to be 7 pi over 4. All right. And for here in quadrant 2, what's that? 3 pi over 4. And quadrant 5, there's no quadrant 5. Quadrant 3 is, I believe, 5 pi over 4. All right, so really the distance here from quadrant 1 to quadrant 3 is pi, is 2 pi. So pi over 4 to 5 pi over 4 is actually just 1 pi. All right, so the distance here is pi, and that's 4 pi over 4. So I just need these. These are duplicates. If I just say x is pi over 4 plus k pi, because their distance is pi. And then I could choose one of these either in quadrant 2 and 3 and just add k pi. And it's 3 pi over 4 plus k pi. You could have put all of those plus k pi, but 2 are repeats, so understanding that is important. All right, back to 8.4. Problem 1. All right, so now I'm on page 555. All right, we have this Ferris wheel. The diameter always tells us the amplitude, all right? All right, it was much larger and slower than its modern. It had a diameter of 200 feet, okay? So, Ferris wheel, diameter is 250 feet, but the radius is 125. That's the amplitude. If we get on here, which is where they tell us that you're going to get on, car D is times 0. So here's where you start, all right? This car D right here. You're going to go up, back down, down, back up. So sine curve, up, back down, back up, all right? So my amplitude, how high up am I going to go? I'm going to go up 125 feet. So my amplitude is 125. And I know it's the sine curve because of the motion. And it says it made 1 revolution every 10 minutes. So from start to finish is 10 minutes. Time is always your period. And remember, period equals 2 pi over b. For the equation, I want this b value. Time is always your period. So 10 is 2 pi over b. Swap our extremes. b is 2 pi over 10, which is pi over 5. So it's 125 sine pi over 5t. It's not been shifted left or right. It's not been vertically shifted up or down.